Well, hello, this is Jack Sheffield, Jack the exam guy. We are going to be talking about ASTM, American Society of Testing Materials, designation E1300-24. This is the standard practice for determining load resistance of glass in buildings. All right. So, first thing we're going to do, we're going to break this thing down, paragraph by paragraph. It is quite involved, so strap in. Okay. So right away, it tells us what this standard is all about. It's issued under the fixed designation E1300. The number immediately following the designation indicates the year of the original adoption, or in this case, the year of revision. Okay. So the 24, so that's the year that it was adopted or revised. Okay. And now a number in parentheses indicates the year of last reapproval. Now there is no number in parentheses, so we're going to assume it has not been reapproved since 2024. A superscript, so superscript is like, at the top, and to the right, pi r squared. The square, the 2 would be the superscript. A superscript epsilon E, so it looks like an E, epsilon indicates an editorial change. Okay, since the last revision or reapproval. Editorial change could just mean maybe something was spelled wrong or something like that. So they, excuse me, made a change. Okay, so that tells us a little about what it is. Okay, so the scope. This practice covers procedures to determine the load resistance, LR, of specific glass types. Now, this includes a combination of glass types, include in a sealed insulating glass, IG. We're going to have to get used to all these, acronyms here. It's a IG unit, or abbreviations, really. Exposed to a uniform lateral load. So this is a uniform lateral load we're talking about. It could be a short duration or a long durations for a specified probability of breakage. All right, so we have a uniform lateral load. We're going to be talking about what they mean by a short or a long duration later. Okay, and then this is a specified probability of breakage, which is the standard we'll also talk about in a minute. Okay, this practice applies to vertical and sloped glazing, all right, in buildings for which the specified design loads consist of wind load, snow load, self-weight, okay, the weight of the glass itself, with a total combined magnitude less than or equal to 15 kilopascals, or 315 pounds per square foot. I think I'm going to be talking about pounds per square foot. I'm going to go with the English measurements instead of the metric measurements, mostly in this presentation, because that's what we're used to. And I think that's what they're going to do have on the exam. Okay, this practice shall not apply to other applications, including but not limited to balustrades, glass floor panels, aquariums, structural glass members, and glass shelves. Paragraph 1.3 tells us that this practice applies only to monolithic and laminated glass constructions of rectangular shape with continuous lateral support along 1, 2, 3, or 4 edges. This practice assumes that 1, the supported glass edges for 2, 3, and 4-sided support conditions are simply supported and free to slip in plane. Glass supported on 2 sides acts as a simply supported beam, and 3, glass supported on 1 side acts as a cantilever. For the insulating glass units, this practice only applies to insulating glass units with 4-sided edge support. Okay. This practice does not apply, paragraph 1.4, to any form of wired, patterned, sandblasted, drilled, notched, or grooved glass. This practice does not apply to glass with surface or edge treatments that reduce the glass length. Now you have a note 1 there. It says ceramic enamel is known to affect glass load resistance. Consult the manufacturer for guidance. Okay, we can do that. 1.5, this practice addresses only the determination of the resistance of glass to uniform lateral loads. The final thickness and type of glass selected also depends upon a variety of other factors. See 6.3. Now, I went ahead and pulled 6.3 up because when we get a reference like that, instead of just moving on like that, what are they talking about? Okay, so there's other types of factors. So when we go to 6.3, many other factors shall be considered in glass type and thickness selection. These factors include, but are not limited to, thermal stresses, spontaneous breakage of tempered glass, the effects of windborne debris, excessive deflections, behavior of glass fragments after breakage, blast, seismic effects, building movement, heat flow, edge bite, noise abatement, and potential post-breakage consequences. Okay, so you got all these other factors that are going to affect our load resistance calculations and what have you. But so there you go. In addition, it says considerations set forth in building codes along with criteria presented in safety glazing standards and site-specific concerns may control the ultimate glass type and thickness selection. So there's a lot of other factors that affect this load resistance and these calculations that we're going to be doing. Okay, very good. 1.6, charts in this practice provide a means to determine the approximate maximum lateral glass deflection. Okay, Appendix X1 provides additional procedures to determine maximum lateral deflection for glass simply supported on four sides. Okay, so the first thing they talk about is these charts. Okay, now if you start looking through the book, you'll see that almost the majority of this book, this standard is these charts. Okay, and we're going to talk in more detail about them, but that's why I just wanted to go ahead and show you real quick what they're talking about when they're talking about these charts. Okay, so this is going to be that. Now this talks about lateral glass deflection, not necessarily load resistance. So those actually are two different things. And there's on each one of those pages, there's actually two different charts. There's the load resistance one at the top, and then there's the actual glass deflection at the bottom. And you can actually do that. If you look at the bottom of below the two charts, it says the upper chart is a non-factored load. Okay, so I don't have this on the screen, but you can read this. It's below on every page where there's charts. There's two captions at the bottom. So for instance, if you're on page 9, this is the first chart. It says your upper chart is your non-factored load chart for 2 millimeter, what they call picture glass, with four sides simply supported. Okay, so that's the other one. That's your non-factored load chart. Now your bottom chart is your deflection chart. Okay, so what kind of deflection you're going to get on these glass panels. Okay, with four, and then this particular page is once again with four sides simply supported. Okay, now the other thing it mentioned that I wanted to in this paragraph is this Appendix X1. And you can look at Appendix X1, it's in the back. It's, of course, Appendix C's are in the back. And we can look at Appendix X1 on page 59. And it says alternative procedure for calculating the approximate center of glass deflection. That's what I've got down here at the bottom. I'm just showing you the heading there at the bottom. But if you look, if you look on page 59, there are some really heavy duty calculations there. And I don't think we're probably going to be really getting heavily involved in this alternative procedure. And that's what it says. These are the alternative procedures for calculating the approximate center of glass deflection. Okay. But we're really mainly talking about load resistance, but glass deflection is important as well. Okay, 1.6, the Appendix X2 lists the key variables in calculating the mandatory type factors in tables 1 through 3 and comments on their conservative values. Okay, all right, so I went ahead and pulled up, I've got tables 1, 2, and 3 there for you. Okay, those are going to be on page 2. All right. So when you do go to the appendix, okay, which they're referencing here, which is based, what page is that on? If we wanted to find that appendix, so it would be on page 2, where's X2? X2 is on, well, there it is. It's on page 53. Okay. This is the, it says a procedure to determine the probability of breakage of monolithic glass. X2 1.1. All right. The GTF, the glass type factor. So now this is the first time we've seen this term. This is a GTF glass type factor. That's actually, I gave you the wrong page. That was appendix A. We're going to be looking for appendix X. Okay, let me give that to you again. Appendix 2.1. There you go. It's on page 60. Apologize for that. Determination of glass factors. Okay. The GTF, the glass type factor presented in these tables, are intended to portray conservative representations of the behaviors of the various types of glass. Rigorous engineering analysis that accounts for the geometrically nonlinear performance of glass lights, glass surface condition, residual surface compression, surface area under stress, geometry, support conditions, load type durations, and other relevant parameters can result in other type factors. Okay, so we're talking about the glass type factors. The appendix talks about how they determine that and what have you. It gets very, very complicated as to how they determine the glass type factors, but these are the glass type factors in this particular table. So let's look at table 1. Well, 3 tables actually. So these are glass type factors for a single light of monolithic or laminated glass. So what is this all about? Why do we have a factor? Well, what happens is based on the type. So we're going to look at these tables and we're going to come up with some numbers, and we have to do a calculation, and we're going to get some numbers, and then based on the glass type, we're going to have to apply a factor to that number. Okay, so you have, your different types, AN. Now, we haven't talked about this yet because we haven't looked at the definitions, but we have our different types over here. AN is annealed, HS is heat strengthened, and FT is fully tempered. So these are your different types of glass, and then the actual factor. And we have a short duration. And now this is the first time we've looked at what they call a short duration, which is 3 seconds. That can be just a simple test question right there. And I tell you what, if I was writing test questions, and I was looking for an easy one, let's just see if these people even have the book. If they have the book, they'll know this, or maybe they're in the field and they understand this and they've looked at this before. But anyway, 3 seconds. A short duration is considered 3 seconds. A long duration is considered 30 days. Okay, so you can calculate your load resistance, your LR. You can calculate your load resistance based on a short duration or based on a long duration. Okay, from 3 seconds to 30 days, and you can actually do it. You'll see another chart where you can do it anywhere in between if you want to do that. Okay, now table 2. Okay, table 2. Now this gets a little more complicated. So it's really simple. Table 1 is really simple. You just got, based on your type of glass or your short or long duration. Okay, do you have your factor there? Okay, so let's get a little more complicated. As we get to table 2, we have a glass type factor for double glazed insulated glass. Okay, and this is short duration. So this table is short duration, so it doesn't break it up into long duration or short duration. But you've got 2 glass types, and you can put, you can actually have different glass types in this double glaze. You can have one panel, or light, they call it, one light being one type of glass and one being another type of glass. Okay, so if it's a double insulated glass, you're going to have 2 lights. So they got light 1 over here and light 2 over here. And then they have the glass type factor. Okay. So this is the factor that we're going to apply when we're determining our load resistance. Okay. Based on the type of glass, GTF, glass type factor. Okay. So we have annealed. We're going to talk more about what annealed is in a minute. Annealed. Okay. If we have a double insulated glass and it's annealed for one light and annealed for the other light, we're going to apply a factor of 0.9 for each one of those lights. If we're combining annealed with heat strengthened, okay, our annealed, the first one, we're going to use a factor of 1.0, and with our heat strengthened, our second light, or glass type factor, is going to be 1.9. Now, what I was looking at is, why is the annealed 1.9 here and we bump it up to 1.0 here? Well, because you're going to be pairing it. This is my hypothetical, my educated guess here is you're pairing an annealed glass with a heat strengthened glass, and so you're going to get a little bit better factor on your glass type factor, just a little bit. Went from a 0.9 to a 1. And then once again, when you team it up with a fully tempered, you're going to use the 1.0 for your annealed, and you're going to use a 3.8 for your fully tempered. When you're doing your calculation, that's your glass type factor. And the rest of the table is very, pretty self-explanatory. If light number 1 is heat strengthened and it's going to be heat strengthened and annealed, you'd use your 1.9 for your heat strengthened and your 1.0 for annealed. It's kind of the opposite. If you just look, when you do an annealed heat strength, you're still going to use 1.9 for heat strength. So the heat strengthened here is 1.9. The heat strengthened once again right here. Now this does drop to 1.8, but it's still very similar if you're using heat strengthened and heat strengthened together. Okay, 2 heat strengthened lights are going to get glass type factors of 1.8, 1.8. And then if you're using heat strength with a fully tempered, then you're going to get a 1.9 for your heat strengthened and a 3.8 for your fully tempered, and so forth. And then you can read the rest. I won't go over the next one with you. But anyway, so that is, this is the glass type factor, double insulated. You got 2 panels, you got 2 lights in this one window. And it's short duration, so that's your 3 second, right? If you're going to calculate for 30-day load, all right, it's a different factor. But it's just, you read this chart the same way. You still got annealed, heat strengthened, annealed, fully tempered, and so forth all the way through. You do a calculation for your first light, you do a calculation for your second light in that situation. If you're sitting down for the exam and this is the first time you're opening this book and you get a question about it, it'll rock your world trying to figure these tables out. It's taken me, several days of going through this manual to try to figure out what some of these things mean. So here we go. So that's a little bit about the tables 1, 2, and 3 are glass type factors. All right, so let's go to 1.8. The values stated in SI units are to be regarded as standard. The values given in parentheses after SI units are provided for information only and not considered standard. What are SI units? Is it Sports Illustrated or what? What are they talking about there? They're just talking about metric, okay? They're going to be talking about millimeters for the most part, okay? And that's going to be, what this particular book uses as millimeters. And it's kind of interesting. I was noticing in a previous slide, I didn't mention it when I was reading it, but they spelled behavior, Behavior. That is a more international way to spell behavior. That's not the way we spell it in the United States. So anyway, so this standard was written really for Canadians, English and that kind of thing, British. So anyway, they're going to use a lot of millimeters. I suspect on the exam they're going to be talking about English measurements, which is pounds per square foot. But just know, and it's like this in a lot of manuals that you'll read nowadays, that they'll have the English measurements in parentheses. Just be aware of that. What's in parentheses is your English measurement. What's not in parentheses are your metric. Okay. And it talks about 1.9, 1.10. The standard does not purport to address all safety concerns, if any, associated with its use. It is the responsibility of the user of this standard to establish appropriate safety, health, and environmental practices and determine the applicability of regulatory limitations prior to use. Okay, there's a little disclaimer. They don't want to be responsible for any safety issues. We're just doing some calculations here. 1.10, this international standard was developed in accordance with internationally recognized principles of standardization established in the Decision on Principles for the Development of International Standards Guides and Recommendations issued by the World Trade Organization Technical Barriers to Trade Committee. So there you go. It's a worldwide kind of a thing. World Trade, so did you say World Trade Organization there? Decision principles. Oh, okay. World Trade Organization. Yeah, World Trade Organization. So that's why we're doing everything in metric here. All right. So the next thing is just your reference standards. Now this is, stuff that they can ask you about in the exam. They can say what other standards are they, are they referring to in this particular standard, and it might be like one of those negative questions, which is the following: is not a standard that is referenced in the ASTM E1300-24, and you'll just say, okay, just look here and say which ones are on the list, kind of thing. So it's a good idea to just kind of know that that's there and what that's all about. Now we're going to talk about terminology. That's always important, and we're going to kind of maybe clarify the few of the things that we talked about already. So it says refer to terminology E631 for additional terms. Okay. 3.2 definitions of terms specific to the standard. Okay, so here we go. 321 acid etched glass surface that has been treated primarily with a hydrofluoric acid and potentially in combination with other agents. Acid etched glass strength shall be considered as equivalent to float glass. All right. Acid etched glass is going to be considered the same as float glass in this practice, provided the glass thickness conforms to the specifications in C1036. Okay, so C1036 is the glass thickness specification. All right. 322, we have something called an aspect ratio. For glass simply supported on four sides, the ratio of the long dimension of the glass to the short dimension of the glass, okay, is always equal or greater than 1. Okay, so you have your long dimension, as long as if it's rectangular, okay, the long dimension is going to be bigger than the short dimension, so it's always going to be more than 1. It could be equal to 1 if it was square. Okay, that means the short dimension equals the long dimension. So it's going to be the long dimension divided by the short dimension, and you get the aspect ratio. Okay, for glass simply supported on 3 sides, the ratio of the length of one of the supported edges. So you're going to have one of the supported edges. Okay, so you can't just take any edge, on when you're figuring the aspect ratio of the supported on 3 sides. You have to take the ratio of the length of a supported edge. You got to take a supported edge perpendicular to the free edge. All right. Okay, to the length of the free edge. So you have to take the length of a supported edge perpendicular to the free edge, because remember, there's 3 sides, so there's going to be one supported on 3 sides, so there's going to be one free edge. And now that's going to be equal or greater than 0.5. I still haven't gotten my head around exactly why that is yet. But we'll, for testing purposes, we'll take their word for it. Apparently, the free edge can be as much as twice as long as the supported edge, and that would create an aspect ratio of 0.5. Okay, so that would be like if your supported edge was 2 feet and your free edge was, that is perpendicular to that supported edge is 4 feet, 2 divided by 4 would be 0.45. Okay. So possibly they don't make the glass that where you're going to have an aspect ratio where your free side on a three-sided is more than twice as long as a supported side. Okay, so here we go. That's aspect ratio. Glass breakage, the fracture of any light or ply in monolithic laminated or insulated glass. Okay, that's pretty self-explanatory. Okay, now let's talk about our thickness. The thickness designation for laminated glass. And we're talking laminated, we're talking about two panels, stuck together, right next to each other. Bam. Okay, a term used to specify a LG construction based on the combined thickness of the plots. Okay, so this is laminated glass, LG. A term used to specify laminated glass construction based on the combined thickness of component plots. Okay, great. Add the minimum thickness of the individual glass plies and the nominal, interlayer thickness. So we don't actually have to, measure that interlayer thickness, which is a good thing because it's tiny, 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 because it's just this inner layer between two pieces of glass that are, right next to each other. Okay, if the sum of all interlayer thicknesses is greater than 60 thousandths of an inch, use 60 thousandths of an inch in the calculation. So this is the interlayer thicknesses. Okay, so we're probably going to be using the 60 thousandths of an inch if it's greater than that. Okay, if the sum of all interlayer thickness, so we're going to have to add the interlayer thickness, and then we're going to have, now that's the nominal. What does that mean? That's just what they call it. Okay, so if they're calling it a certain thickness, regardless of the actual, if we took a little tiny, tiny little microscope and looked at the actual thickness of it, measured the exact thickness, that doesn't count. I'm just going to use the nominal thickness, whatever they call it. That's for the interlayer, though. Now it's going to be the minimum thicknesses of the individual glass plies. Okay. That's the actual measurement. That's going to be the actual minimum thickness of the individual glass plies when we're figuring out the thickness of the glass. Okay. And we're going to select the nominal thickness or designation from table 4, having the closest minimum thickness that is equal to or less than the value obtained in 3241. This is our thickness. Okay. And we're talking about, they're referring back to this one. So they're referring back to 3241, one of the parentheses. They're referring back 2 paragraphs back. So basically, whatever they tell us the nominal thickness is, we're going to go to table 4. I'm going to show you that in a minute. We're going to go to the next lowest value, and that's the actual number we're going to use. Okay. Maybe that'll make sense in a minute. Exceptions: the construction of 2 quarter-inch glass plies plus our 15 thousandths of an inch or 30 thousandths of an inch interlayer shall be defined as half inch. Okay, so it doesn't really matter. Okay, we're just going to call 2 quarter-inch planes. We're going to call it half inch, regardless of if we're adding a 15 thousandths of an inch or a 30 thousandth of an inch interlayer, we're still going to call it half inch. We don't have to add in the interlayer. The construction of 2 3/32 glass plies plus, a 60 thousandths of an inch interlayer shall be defined as 3/16. Okay, yeah, it just depends. They're not going to worry about, in these very common type of thicknesses, they're not going to worry about adding in the interlayer. Okay, we're just going to call, 2 pieces of laminated 3/32. We're just going to call it 3/16, regardless of what the interlayer is. Okay, the construction of 2 5/32, glass ply plus any thickness interlayer shall be defined as 5/16. Okay, so these are some exceptions about how you're going to calculate that interlayer on these very common and smaller type of lights. Okay, so one thing we didn't see is we didn't see table 4 yet, and here is table 4. Okay, So table 4, the numbers we would use if we're doing the calculation, if it was a 2 millimeter, what they call a picture window, we would use 1.8 millimeters or 0.071, 71 thousandths of an inch when we were doing our calculation. There's been a lot of information so far. Are you picking up on it? Wow. Okay. 3242. Okay. We're still talking about terms here. We're still talking about definitions, terminology. Okay. 3242. Thickness designation for monolithic glass, a term that defines the designated thickness for monolithic glass as specified in Table 4 and specification C 1036. So there it is. We already looked at Table 4. We know what that's about. And when we're doing our calculation, if we have to do a calculation, and they give us a nominal size, we're gonna go to Table 4, and the next smallest number is what we're gonna use in the right-hand column. Okay, just to be on the safe side and be, have a conservative number, they call it. Okay, except in those exceptions, remember, okay, that we talked about as well. Okay, so here we go. Glass types. Okay, so you have anneal glass. Okay, it's a noun. They tell us what part of speech it is. I found that kind of interesting. At first I was looking at what are they talking about? N. What do they mean N? And then I saw one where you'll see it in a minute where it says ADJ, which means adjective. And so okay, so the N means noun. Okay, great. So we're talking about what is anneal glass? A flat monolithic glass light of uniform thickness where the residual surface stresses are nearly zero as defined in specification C 1036. Okay, so there's no residual surface stresses and it's called annealed flat monolithic glass. And that didn't really do it for me because I'm thinking annealed, what does that mean? Well, so I looked on the internet and so this is the definition. Annealed glass, also known as standard or float. Remember float glass? We talked about that. And the other glass that was going to be used as the same, we're going to call it this, we're going to treat it the same as float glass. Okay, so now we've got some terms that we're starting. Okay, so we have float glass, we have anneal glass, are the same, and we're going to treat that other glass as the same. What glass was that? Was that etched? That glass that we were going to talk about. Let's see. Practice applies. For instance, this only applies. This practice does not apply to any form word. Does not apply. This practice addresses only the determination. Final thickness. Blah blah blah. Charts in this practice. Appendix 8 provide. Monolithic. I'm looking at 1.3 now. This practice assumes that that's for insulating glass use practice only applies to insulating glass with four-sided support. Anyway, okay, it's acid etched glass. That was actually the first definition. Acid etched glass is shall be considered as equivalent to float glass. Okay, well now we know what we've got a couple of terms. Anneal, so this is like your standard. That's what it says here. Standard. This is our standard glass, anneal. Okay, as the most basic form of glass has undergone controlled slow cooling process called annealing. If I call it anneal, I guess. Okay, to relieve internal stresses while it is weaker and breaks into dangerous sharp shards, unlike safety glass. Annealed glass is cost effective, can be easily cut and customized, and is suitable for applications like tabletops, okay, cabinet doors, decorative features where high impact resistance is not a priority. Okay, so this is your standard glass. Okay, anneal. All right, very good. All right, now, fully tempered, FT 3252. We're still talking about glass types here. A flat monolithic glass light of uniform thickness that has been subjected to a heat treatment process where the residual surface compression is not less than 10,000 psi, or the edge compression not less than 9,700 psi, as defined in specification C 1048. Well, there you go. That's like a test question waiting to happen right there, I got to tell you. All right, Heat strengthened glass, 3253, okay, a flat monolithic glass of uniform thickness has been subjected to a special heat treatment process where the residual surface compression not less than 3,500 psi or greater than, okay, not less than 3,500 or not greater than 7,500 psi as defined in specification C1048. Insulated glass, IG. Okay, so we have HS, heat strengthened, IG, insulated glass, any combination of 2 or 3 glass lights that enclose 1 or 2 sealed spaces, respectively, filled with air or other gas. Okay, so we all know what insulated glass is. Double insulated could be, could be 3 units, could be 3 panels. It says it could be 2 panels or 3 panels with spaces in between. Okay, laminated glass. A flat light of uniform thickness consisting of 2 or more monolithic glass plies bonded together with an inner layer as defined in specification C1172. So there you go. It could be laminated glass. And all these little specification numbers, these are all fair game in exams, okay? Just, I mean, what is the specification, on laminated glass? Well, there you go. Specification C, where it talks about the 2 monolithic plies bonded together with an interlayer material. Okay, we talked a little bit about that. Okay, discussion. Okay, so discussion. Number 1, many different interlayer materials are used in laminated glass. The information in this practice applies only to polyvinyl butyl, okay, PVB interlayer, or those interlayers that demonstrate equivalency according to Appendix X8. And whenever they mention an appendix, I like to take a look. Okay, so basically what they're saying is there's other stuff, there's other materials that are equivalent to the PVB, the polyvinyl butyl, and in Appendix X8, that's where they tell us all about it. And that is at the top of 63, and they have a method for establishing that equivalency. Wow. Okay, so we're not going to go into that in much detail, certainly not now. Maybe towards the end of this presentation, we may look a little bit more at that X8. The purpose of it, I'm just going to read it for a second on page 63. The purpose of this appendix is to provide the criterion for specifying when the non-factored load resistance charts, non-factored load resistance charts for PVB laminated glass may be used for laminated glass made with plastic interlayers other than PVB. Okay, it's going to get pretty technical there, I can tell you that. Okay, very good. All right, so more glass types. Glass type factor. Okay, we talked about this a little bit. There's going to be a factor. We looked at those tables 1, 2, and 3. A multiplying factor for adjusting the load resistance of different types of glass. That is, annealed, heat strengthened, fully tempered in monolithic glass, laminated glass, or insulated glass construction. A monolithic, laminated, or insulated constructions. Okay, lateral. What does lateral mean? Perpendicular to the glass surface. Load, a uniformly distributed lateral pressure. Glass weight load, the dead load component of glass weight. When they're talking dead load, there's two types of loads that you have in a building are live load and dead load. Dead load just means the weight of the material. Okay, it's the weight of the material in a building. That's the dead load. Live loads can be people moving around in the buildings. It can be wind. It can be other things. But dead load is the easiest to describe because it is just the weight of the components. Okay, now 3282 load resistance, the uniform, once again, uniform lateral load that glass construction can sustain upon a given probability of breakage and load duration. We're going to discuss a little bit. There's a discussion here multiplying the non-factored load. So you've got, when you look at the chart, you're going to get a non-factored load. Okay, but you multiply that. Okay, multiplying the non-factored load from figures A1 by the relevant, okay, glass type factor and load share LS factors gives the load resistance associated with the probability of breakage or equal to or less than 0.008. Okay. And that's a number, that's the first time we see this 0.008. This is what they call the breakage probability, okay, is going to be 8. So I did look it up on the internet. It's an architectural term. A standard architectural term is you will get a probability of breakage under those conditions in 8 out of 1,000 panels. Okay, that's the best that I could determine is what they're talking about. 8 out of 1,000 panels is the probability of breakage point. That's what 0.008 is. Okay, now annexes, and it talks about this annex. So I went ahead and looked at this non-factored load charts. Okay, so now we're looking at our non-factored load chart, and that's at the bottom of 8, and that's where it says an NFL non-factored load chart are presented in the upper charts of figures A1. So when you look at these pages, it's the upper chart. Okay, the one on the top is the non-factored load chart. Okay, were developed using a failure prediction model for glass. Okay. The model allows the probability of breakage of any light or ply to be spent. See this 5 and the 6? We're going to talk about that in a minute. The model allows the probability of breakage of any light or ply to be specified in terms of 2 surface flaw parameters, M and K. Okay, this is getting a little more technical. I'm not going to go into that right now, but these are the charts they're talking about, non-factored load chart. We're going to take that non-factored load chart, and then you have to apply these factors. First, we have to learn about how to use the non-factored load chart. Wow. Okay, we got a little few more terms to go through here, and hopefully some of this will get clarified as we go through it. 3283, long duration load, any load lasting approximately 30 days. There you go. That's our long duration again, 30 days. We saw that before. For loads having duration other than 3 seconds or 30 days, refer to table X41. And you can find table X41 in the back. This is a, once again, it's in the back. It's in an appendix X41. Okay, X, that's A. Okay, we're going to look at X41. That's on page 61. And it says, okay, so this is 3 seconds where it's a factor of 1. What was our other one? 30 days. 30 days, 1 month is 0.43. That's another one. But here is our load, this is for the purpose of, is a calculator to convert, multiply the load resistance by the factor in X41, okay, 3 seconds to a load duration listed in X41. So if you have to factor this based on something other than 3 seconds, because that's where it says 3 seconds here, loads having a durations longer than 3 seconds, or 30 days, refer to table X41. But here it is right here, and you can make that calculation right there. Once again, you'll see this 0.008. There you go. That's the probability of breakage again, 0.008. 8 lights in 1,000 under these conditions will break. Okay. All right. Very good. And then we have a non-factored load, 3 second duration uniform load associated with the probability of breakage less than or equal to 0.008 for a monolithic annealed glass as determined from figures Annex A1. So here it is right there. This is our table. We're going to look a little more in detail about how to calculate that later, but I just wanted to show you this table again. This is the top of, all those pages and that are the majority of this book. This is the top. You can see it says, this is your type of glass. This is your non-factored load. That's what we're looking for here. This is your 4 sides. Now, this is a 4-side simply supported glass. You got to make sure if you're doing these, you got to use the right glass, right? Okay, and here's your 0.008 again. This is your probability of breakage. Now, this is what the actual pressure is. Okay, so this 1 kilopascal is going to be equal. So this is actually in kilopascals, and if you want to convert it to PSF, pounds per square foot, you're going to have to multiply times 20.9. And this is a 3 second duration. So all these are going to be 3 second durations. There you go. And once again, you got this thing at the bottom of the page, which is going to tell you the upper chart, which is this one, is the non-factored load, okay? And then you're going to have a lower chart, which is deflection. Wow, there's a lot of stuff here. Amazing stuff. All right, short duration load, once again, any load lasting than less than 3 seconds or less. Specification design load, the magnitude in pounds per square foot or kilopascals. The specified design is the magnitude in kilopascals or pounds per square foot type, for example, wind or snow, and the duration of the load, okay, given by the specifying authority. That's going to be our design load. Okay, so it's going to be the PSF and the duration. Okay, load shear factor. Okay, the portion of applied load going to a particular light in consideration in a sealed insulated glass unit, whether the light be monolithic or laminated glass, including the layered behavior of laminated glass under long duration loads. Our load chat, what in the world did they say there? The portion, the load shear factor, the portion of the applied load going to a particular light. So you may have two limit, and okay, so you got a sealed insulated glass unit. You're going to have a load shear factor for one light and a load shear factor for the other. Whether the light be a monolithic glass, okay, or laminated glass, including the layer behavior of laminated glass under long duration load. So you got two different panels, and there's going to be a load shear factor right there. Okay, discussion. The load shear factor is used along with the glass type factor and the NFL, the non-factored load value from the NFL charts to give the load resistance of the insulated glass unit based on the resistance of breakage of one specific light only. So if you've got laminated glass, that's if one, that's not for both of them to break, that's for one of them to break. If one of them, you know, that's the load, that's going to be the load resistance of one light. That the load resistance that would cause one light to break only. Okay. Pattern glass. Okay. That's a noun. A rolled flat glass, a rolled flat glass having a pattern of one or both surfaces. Okay, a pattern of one or both. That's not all too complicated. Okay, 3 to 11. Probability of breakage. The statistical likelihood that a given light or ply would break at the first occurrence of a specified load, typically expressed in a decimal format when larger than 0.001, and scientific notation when less than 0.001. Okay, so we're doing, and we usually use 0.008. I wish they would have given us a little bit better definition on that. Okay, 3, 2, 1, 2. Sorry, it's a little blurry. Sandblasted glass, flat glass with a surface that has been sprayed by sand or other media in high velocities to produce a translucent effect. Okay, not a big deal. 3, 2, 13. Specified authority, the design professional responsible for interpreting applicable regulations of authorities having jurisdiction. Okay, and considering appropriate site-specific factors to determine the appropriate values used to calculate the specific design load, and furnishing other information required to perform this practice. Okay, so that's going to be the specifying authority is the design profession. Okay, interesting. All right, wired glass, a flat glass with a layer of wire strands or mesh completely embedded in the glass. We know what. That's the end of part 1. I think I'm going to stop part 1 there. We had the first section, which was scope. We had the second section, which was reference standards. And then we had all this terminology. We looked at some tables and things like that. We're going to move on to material properties on the next video. Thank you for watching. This is Jack Sheffield, Jack the Exam Guy.